There's, first of all, good morning. Thank you for coming in today. There are a lot of things that I don't like, and one of those things is missing school. Especially when it's unexpected, it's really hard for me. Like, I don't like missing school. Getting a sub and planning and all that is terrible. And I wanted to finish this lesson, and so the best thing that I could think of is to record a video. And I've been getting into some editing lately, so I think maybe recording a video and putting some example problems down would be good for us. So let's try this out. I don't know how it's going to be, but I'm sorry that I couldn't be there today, and let's go for it. All right, so we got our trig functions table. I think we got through the first one or two yesterday. So we say sine of any angle, right? All right, so we got our unit circle here. Can we see that on the screen? We got all of our degrees, we got our radians going around, and all the points that correspond to the t-values. Now the t-values are the angles, right? And so my very first angle right here would be 30 degrees. That would be the t-value of pi over 6. Now sine of any t-value is always the y-value, right? Because sine is opposite over hypotenuse, and all of the hypotenuse, like we talked about in class yesterday, are always equal to 1. It also turns out that cosine of my t-values, right, which we learned before in previous classes, is adjacent over hypotenuse. And if you think about this triangle, right, if I bring this down, this is my t-value. Adjacent is going to be this x value right here, right? And my hypotenuse, which is the unit circle, is always 1. I mean, would you agree that all of these hypotenuses or hypotenusi or whatever that would be is always equal to 1, right? So this value, cosine, is adjacent over hypotenuse, which would be adjacent over 1, which is just adjacent, is always going to be the x value. Now, tangent of t, right? We learned as SOHCAHTOA, tangent is TOA, which is opposite over adjacent. If you look at your triangle, opposite is the y value and adjacent is the x value. So every time I'm trying to find tangent would be opposite over adjacent or y over x. All right, now 3 new trig functions that go with this. They're called the reciprocal functions. S for sine pairs up with c. This is called cosecant, right? Now cosecant of t is the reciprocal. So 1 over sine, which is cosecant, is the reciprocal of sine, is going to be called 1 over y. These are listed on page 359 of your book. You want to look at these as we kind of go through them, right? Cosine starts with c, secant starts with s. Those are opposite letters. So secant of t is going to be the reciprocal of cosine, which is 1 over x. And the other one that goes along with it is cotangent. COT is cotangent of t, is the reciprocal of tangent, which is going to be x over y. And we're going to look at an example right now. All right? Let's find all 6. Here's example 1. We did like a quick brief example yesterday. Let's find all 6 of, let me go 5 pi over 3. Okay? And when I say all 6, I mean all 6 trig functions of 5 pi over 3. So let's start off with sine. Sine of 5 pi over 3. Well, let's get out our unit circle. So 5 pi over 3, we need to find this on the unit circle. Oh, which I found right here is at 300 degrees. I'm going to write this coordinate down. 1/2, comma, negative root 3 over 2. I'm going to put that here at the top of the page. This is going to be 1/2, comma, negative root 3 over 2. This is the coordinate that I'm going to be using for all 6 trig functions. Now, sine, according to my table, is the y value, and the y value is negative root 3 over 2. Done. The problem is over. Next, cosine of 5 pi over 3 is going to be the x value, and the x value of the corresponding angle is positive 1/2. Now, let's mess things up a little bit. Tangent of 5 pi over 3 is going to be y over x. Let me write this down here real quick. Y over x right? So my y value is negative root 3 over 2 all over x, which is 1/2. I'll give you half credit for this because it is not simplified. You will find fractions over fractions very often. What I want you to do is take the bottom fraction and flip it. I change to multiply and reciprocal of the bottom. Notice the 2's will cancel. And the final answer, the final simplified answer here is going to be negative root 3. I want exact answers, no decimals. If you plug these things in the calculator, you get decimals. I don't want any decimals for these. Now, the reciprocal functions. Easy to find, but we want to simplify them. Let's see. Sine, the reciprocal of sine is cosecant. CSC of 5 pi over 3. It's going to be the reciprocal of what I've found, negative root 3 over 2. Let's call it negative 2 over root 3. That's cosecant of 5 pi over 3. However, a mathematical rule that says I cannot have a root in the bottom, I need to rationalize. I need to multiply it by itself. If I multiply by a root 3 on the bottom, I need to multiply by a root 3 on the top. On the top, I have negative 2 root 3, and root 3 times root 3 is root 9, which is just 3 on the bottom. That is the simplified version of cosecant of 5 pi over 3. Let's try the same thing with secant. Whoops. Secant of 5 pi over 3. It's going to be the reciprocal of cosine, and the reciprocal of 1/2 is just 2. That one was easy. Cotangent of 5 pi over 3. Now, notice that it's just negative root 3, which I can find the reciprocal as negative 1 over root 3. Which again, I need to rationalize. Multiply this by root 3 over root 3 to get the root out of the bottom. On the bottom is just 3. On the top is negative 1 root 3, which I can write as negative root 3 over 3. Final answer for cotangent. In the next example, I want to do one of the quadrant angles. So we have example 2. Let's do the same thing. Let's find all 6 of t being, let's go negative, 3 pi. Might be interesting. Now I notice if I go back to the unit circle, 3 pi is not even on here. Right, and so what I need to do, if I go all the way around once, that would be 2 pi, right? And then another half of a circle would be 3 pi. And negative 3 pi would just be in the reverse direction. So if I go negative 2 pi in this direction, and then another half a circle would take me to negative 3 pi, which is technically the same thing. And that's negative 1, 0. So let me write down the corresponding coordinate that goes along with 3 pi, and we'll use that to answer the questions. Sine of 3 pi, sine of negative 3 pi is going to be the y value, or 0. Cosine of negative 3 pi is going to be the x value, or negative 1. This is easy. Tangent of negative 3 pi is going to be y over x, which is 0 over negative 1, which is just 0. That's good. Now, what about cosecant of negative 3 pi? It's the reciprocal. And the reciprocal of 0 is technically 1 over 0. That gives me 0 in the denominator, so cosecant of negative 3 pi is undefined. All right? Secant of negative 3 pi, right, is the reciprocal of negative 1. Let's call that negative 1 over 1, which I guess really this is negative 1 over 1, so we should call the reciprocal 1 over negative 1. I guess it really doesn't matter. So 1 over negative 1 is still just negative 1. Negative 1 is the reciprocal of itself. And cotangent of negative 3 pi, the reciprocal of 0 over negative 1, which we had, I guess is just still puts 0 in the bottom. That's also going to be undefined. All right? So those look pretty good. All right, one of the last things that I want to show you, and we're going to be done for this video, is some of the negative angles, right? We're going to talk about some of the flipping around. So if I just grab one here, if we say sine of negative 210, right? Instead of thinking about, I mean, I can find 210 easy on the circle. 210 is here. If you're going to have a negative angle, you're going to flip up or flip down. Never flip side to side. If I find 210, which by the way is equal to 7 pi over 6, I don't have this labeled on my circle. This one's also 225, which is 5 pi over 4. I don't have that labeled. I guess this is 8 pi over 6 or 4 pi over 3 here, okay? 210, if I flip up, a reflection directly to the top, right? So negative 210 and 150 are equal because a positive 210 would be in this direction and negative 210 would be clockwise, which would land me at 150, right? So I want to use the coordinate that goes with negative 210, which is negative root 3 over 2, comma 1/2. Sine is the y value, so that's going to be equal to 1/2. So I wanted to talk to you about that with negative angles. The last thing that we're going to talk about today is typing these things in a calculator. There are some questions in the homework where they ask you to put these in a calculator. If I have you type in sine of 74 degrees and then sine of pi over 9, okay, this is really easy to type in, but it's really easy to mess up because you have to be able to change the mode. This is where the mode matters, right? If I have a degree and I'm evaluating sine, cosine, or tangent, click your mode key and make sure you're in degree mode. If I have a radian, I got to make sure that I'm in radian mode, and it says in the book to round to 2 decimal places. Let me grab my calculator. Okay, so what I have here is sine of 74. Let's go to mode, which is here, and check. My mode is in degree, so I can second quit, and I can go sine 74, which is going to be here, and this is going to be 0.96. So round to 2 decimal places is 0.96. I guess technically we need an approximately equal to symbol, which is like that. And sine of pi over 9, I need to go to my mode and change it to radian because I'm doing sine, cosine, or tangent in the calculator, and that's going to be sine of second caret over 9. There's sine pi over 9, which is 0.34. So I hope this has been a little bit helpful for you. Again, I'm sorry I'm not in school today. I want to give you some problems to work with. So again, I'm sorry that I could not be in school today, but I hope this has been helpful for you. Have a great day, and I'll see you on Friday.